Fine. Is it visible to you? PDF is visible, guys?
Yes, ma'am.
Yes, ma'am.
Yes.
Fine. So we have learned about the indicator, acid, different types of acid, and like only up to acid. So what are the physical properties of acid? See? So just give me a while, okay? Hello? Fine. Just a minute, okay? Fine. So physical properties of acids are there that actually I wanted to explain you. Okay, then we will see the chemical properties of acid, and then about bases we'll see later. Fine? Is it okay?
Yes, ma'am.
Fine. So see, very basic things about the acids. So acid present into the lemon, into tamarind, even into the tomato, we have seen, isn't it? So these all fruits and even the veggies which we have like quite sour in taste, right? Lemon is sour in taste. Then tomato is also sour in taste. Why? Because presence of acid. And even if you see the curd, in curd also lactic acid is a present, and that is also sour in taste, isn't it? So the first property of acid is what? Acids are sour in taste. Then the next one, they can change blue litmus paper to red. Okay. So litmus paper test you have done in your grade 7th, you have done in your grade 8th, even in your grade 9th. Also, you have learned about the litmus paper and even color of the litmus paper. There are the two litmus paper, right? Right? One would be red. Another would be blue color.
Blue.
So what is the specificity of this red color litmus paper? It remains red into the acid and it will turn into blue in the bases. Red litmus paper remain red into the acid and it will turn blue in the bases. And blue litmus paper remain blue in the bases.
Bases.
Okay, and it will turn red into acid. Fine. So the basic property of the acids are it can change the blue litmus paper into red. Then the aqueous solution of acid are very good conductors of electric current. Why aqueous solution of the acids are very good conductor of the electric current? Because for the acid, like suppose HCl, when you dissolve it into the acid, it get dissociate as a H++ Cl-. Okay, it has a two different ion, positive and negative. Positive ion is called as what? Cation. Negative ion is called as what? Anion, right? And these two ions, oppositely charged ions, are responsible to conduct the electricity in the aqueous solution of acids. Clear? Yes or no? For the HCl, it will be dissociate as the H+ Cl-. But then if you see the H2SO4, yesterday only I gave you the dissociation of this, right? Twice H+ plus SO4, 2-. So dissociated into the positive and negative ion acids when you dissolve it into the water, and hence they can conduct electricity in their aqueous solution. Fine. The next fourth one, acids are very highly corrosive in nature. Corrosive means it can damage your senses. Okay. They are highly corrosive in nature. If it fall on your skin, it can cause a burning sensation on your skin, or it can burn your skin completely. Fine. So they are highly corrosive in nature. So these are the four characteristics, basic properties of a acid. If you want to note down, please note it down. After that, we are going to learn about the your chemical properties for the acids. Are you writing this?
Yes, ma'am.
Fine. Hurry up fast. Once you have done, let me know. So once you have completed with this, I will just show you your white screen where we are going to learn about the reactions. reactions or the chemical properties of acid one by one. Done?
Yes, ma'am.
Fine. So I hope whiteboard is visible to you all. Now we are going to learn about chemical properties of acids. Okay. So generally, you have to keep these acids in your mind, because whenever you have to, it's like write something about the chemical properties of acid, you have to write regarding with these acids only. HCl, H2SO4, and HNO3. These are the mineral acids or inorganic acid. So name of these acid already you are aware. This is hydrochloric acid. Okay. This would be sulfuric acid. And this is what? Nitric acid. Okay. Now the first reaction of acid with metals, right? Yeah. So I think you might have not learned about your activity series of metal yet. Okay. But then for your understanding, I'll just give you here. And there is one statement to keep these things in your mind. Okay. One rhythmic center series is there that I'll give you. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, and gold. Okay. So how you're going to keep this in your mind? One sentence is there. I hope all of you are aware of the Hindi. Hindi?
Yes, ma'am.
Yeah. Okay. So I'll just give you one sentence for that. That would be what? करीना ने कार मांगी अल्टो जेन फरारी फिर भी हाथ क्यों है जी सिल्वर ऑडी पुरानी for the platinum. Okay. So with this sentence, you can keep this sequence in mind. If you want to follow this, you can, or else you can keep it in your mind as it is how I have written. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, then the mercury, silver, gold, and platinum. Okay. So this is the sequence. What is the reason why I gave you this series? To understand the reactivity of your metals. So these metals like potassium, sodium, and calcium, these are highly reactive metals. How they are? Highly reactive metals. And from magnesium onwards till the lid, or till the lid, they are moderately reacted. Moderately reactive metals. And copper onward, they are least reactive. Among that, silver and gold are called as noble metal. Why? Because they occur in the earth crust in the free state. not silver exactly, but then gold and platinum occur into the free state. Okay. They do not react with the any another substance easily, even not with the oxygen. And hence it is called as noble metal. Now, these all things we are going to learn in your another chapter, that metal and non-metal chapter is there. So in that we are going to see it in detail. I'll just give you understanding this sequence because you have to react it with your acids. In acid, what is present? Hydrogen is present, right? Yes?
Yes, ma'am.
So electropositive element in your acid is nothing but hydrogen. Metals are how? Metals are also electropositive in nature. Right? So whenever you react metal with your acids, it will be replace the hydrogen from your acid. And replacement of the acid is completely depending upon what? The reactivity of that metal. If that metal lies below the hydrogen, then replacement does not happen. Understanding? If that metal is below the hydrogen, then replacement does not happen because copper, mercury, silver, and gold. These are the least reactive metal, and hydrogen is above it. So these less reactive metal cannot displace hydrogen from its compound, and hence displacement reaction will not be happen. But then if the metal is from potassium till the lead, then yes, reaction may happen. Displacement would be takes place. Clear?
Yes,
Could you repeat that short
one
form?
more. Sorry?
That Karina you said, no, ma'am.
Achha, the statement you want.
Yes, ma'am.
Yeah, that is what करीना ने कार मांगी अल्टो जेन फरारी फिर भी हाथ क्यों है जी अल्टो जेन पुरानी sorry silver Audi पुरानी not alto silver Audi पुरानी silver for the AG Audi for the gold and purani platinum. Okay.
Ma'am, could you be slow, ma'am? I did not hear.
I have to write it.
Ma'am, please.
Oh my God. Okay, fine. Everybody want or only he? Guys, come on, speak up.
Ma'am, me also.
That's what, if you won't speak, how I come to know? Right. Copper, huh? This is copper. Okay. This silver Audi Purani, this three would be here, huh? AG, AU, and platinum.
Thank you.
Fine. Everybody done?
Yes, ma'am.
Shall I erase it? Shall I erase it? Anybody have any problem? If you want to take a screenshot, you can. It's up to you. I'm going to erase it. Shall I? No reply. What is to be done? I want to understand why won't you speak? Fine, let it be. So generally, reaction in between metal and acid. When metal and acid react with each other, it will be formed salt. Okay, metal salt, and hydrogen gas would be released. So what exactly happened generally with that? All three acids we are going to see. Okay. In that, see, check. First of all, your HCl, sorry, metal, any metal I'll take. Any of the metal. You only tell me which one should I take. Shall I take sodium? Na.
Yes, ma'am.
When it react with acid, hydrochloric acid, right? So salt will be formed into what? This metal and this chloride ion. Because what I told you, your hydrogen is electropositive and sodium is also electropositive. So electropositive element will replace electropositive element from their compound, right? Yes or no? So you will get here NaCl as a salt and hydrogen would be released as a gas. Now hydrogen is not a nascent in a nature, right? It never exists into H form. It always exists into H2 form, in a molecular form. Correct? It's a diatomic gas. So to make it H2, you have to balance it, right? If here is a 2 hydrogen, you have to multiply this HCl by 2. Now your chlorine also become how many? 2. And to balance it, this need to be multiplied by 2. Sodium become 2 and hence number of sodium metal also should be 2. So this is a balancing chemical equation which you have learned into your previous chapter. Have you learned it or not?
Yes, ma'am.
Anybody have any problem in a balancing? If it is so, let me know so I can explain it again.
No, ma'am.
Yeah. Fine. I hope all of you understood this. Right?
Yes, ma'am.
Yeah. So whenever there would be a metal reacted with hydrochloric acid, it will form metal chloride. Generally, correct? Yes or no?
Yes, ma'am.
Whenever your metal react with hydrochloric acid, it will give you metal chloride and hydrogen gas. Now, in this way, any of the metal can be react with this, right? I can take aluminium reacted with HCl. What it will be formed? Aluminium valency is what? Last year you might have learned. Aluminium valency is +3. Chlorine is -1. +3 -1, go for the cross multiplication. Al1 is a Al and Cl3 is a Cl3, correct? So this will be aluminium chloride would be formula for your salt, right? And hydrogen gas would be released. Clear? Yes. Is this reaction balance? No, right? You can check here. How many chlorines are present here? 3. Here it is 1. But then if I multiply it by 3, your hydrogen here become 3 and your hydrogen here are 2. So to balance it, first of all, this odd I need to convert into even. And for that reason, this AlCl3 need to be multiplied by 2. Clear? Yes or no? Odd number of chlorine I have converted into even by multiplying this entire molecule by
Yes, ma'am. Yes.
right.
2.
So your chlorine become 3 2s are 6. Here how many chlorine? Only 1. To convert into 6, I supposed to multiply this entire HCl by 6. So your chlorine becomes 6 and your hydrogen also become 6. Right? Yes. Here hydrogens are only 2. To convert it into 6, I should multiply it by 3. 3 2s are 6. Right? And aluminium here 2. And to balance it, I should multiply this aluminium also by 2. Clear?
Yes, ma'am.
Yes, ma'am.
In this case also what happened? Metal reacted with the hydrochloric acid, form a metal chloride and hydrogen gas is released. So it matches with your general reaction. This is your what? General reaction. Got it? Okay. If you have noted down, it's fine. I'm going to show you the reaction of H2SO4 with this now. Shall I erase it?
Yes.
Yeah. Now how H2SO4 would be react? H2SO4 is sulfuric acid. Correct? Yes or no? Now, in this case, what happened? Again, the same way, general reaction, metal reacted with sulfuric acid, H2SO4, sorry. You will get what? Here it is sulfate group, right? So it won't give you metal chloride. It will give you metal sulfate salt, right? And hydrogen gas would be released. Okay. In HCl, what we get? In HCl, you get metal chloride. In H2SO4, you will get metal sulfate. Okay. Now, any of the metal, suppose the same sodium I will take. Your H2SO4. Your one of the product is what? Hydrogen, it's confirmed. Now metal sulfate you have to form. Metal valency you should be aware. Metal valency is what? Na. It has a valency +1. sulfate group, SO4 minus 2, plus 1 minus 2, go for the cross multiplication, Na multiply by 2, you will get Na2, SO4, 1 SO4, that is SO4. Okay, so your metal sulfate would be Na2SO. Clear? Right? You can check here, 2 hydrogen is there. Right? Here is 2 hydrogen. 1 sulfur, 1 sulfur. 4 oxygen, 4 oxygen. Now here 2 sodium and here only 1 sodium. And for balancing, this sodium need to be multiplied by 2. So this is a balance equation. Clear?
Yes, ma'am.
Fine. See the next one now. Any another thing which you want, like FeSO4? Shall I take ferrous, iron? Fe reacted with H2SO4. What will happen? Can you write down the equation for this? Students, I'm facing
Good.
network issue. I hope you are not facing any sort of network issue. So you can
No,
open
ma'am.
your, right? All of you are just keeping off your video and I'm not understanding whether you're means like with me or you're just copying the things. I don't want like that. You have to open your video. You have to unmute yourself, ask your doubt, keep asking.
Fe2O3,
Hmm?
Fe2O3 plus SO2.
Fe2 O3, O3 why?
SO4.
Why? SO4, right? Yes.
So
It won't be.
FeSO4.
Yes. Fe will be replace your hydrogen, right? It is electropositive. It is also electropositive. Correct. So you will get here what? FeSO4. The reason is what? Fe has a valency plus 2. Sulfate has a SO4 minus 2. Plus 2 minus 2. 2 ones are 2. 2 ones are 2. Both get cancelled. And hence you get the formula FeSO4. Clear?
Yes, ma'am.
And your hydrogen gas would be
Yes,
released.
ma'am.
Yes or no? Fine. Now, is there need to balance anything? No, everything is balanced. So what you come to know, when metal react with sulfuric acid, it will give you metal sulfate and hydrogen gas is released. Okay. So how you should understand whether hydrogen gas is released or not? What would be the properties of this hydrogen gas? First thing,
Ma'am,
this
when the
hydrogen
gas burns, it burns with the purple
colorless
sound.
and odorless. Right? This is combustible or non-combustible gas. Can you tell me? Hydrogen gas is a combustible gas or non-combustible gas?
Combustible.
Combustible.
Okay, it can undergo combustion. Fine. And the lastly, it burns with
A pop sound.
pop sound. Very good. Clear? Yes? Fine. So
Yes,
these are the
ma'am.
now a very important tricky point in this that you need to be focused. Shall I erase this all?
Yes.
Yes, ma'am.
Fine. So now we are going to see about this HNO3. What is the name of this acid?
Nitric.
This is what? Nitric acid. Now what happened when I react with metal with HNO3? This is a nitrate group, right? So I will get here metal nitrate plus what, guys?
It's two.
What I'll get? Plus H2O. Now the change is what? In earlier equations with the HCl and the H2SO4, we have written what? H2 gas is released. But then here you have written H2O. Why? Any one of you have any like sort of thinking like why it's happened? Just give me a 2 minutes. I'll finish my tea till the time you just think and let me know what is your opinion about it. Okay.
Okay, ma'am.
Nobody have any answer?
Yes, ma'am.
Have or not?
No.
Okay, fine. So what happened? This HNO3, it's a nitric acid. This acid is strong oxidizing agent. Okay. So whenever in this reaction, your hydrogen gas would release, this hydrogen gas would be oxidized by this HNO3 and converted into H2O. Understand? And hence, in case of nitric acid, hydrogen gas does not release. Instead of that, water molecule is released. Okay? Understanding? Yes or no?
Yes, ma'am.
Once again, I'll repeat. Nitric acid is what? Strong oxidizing agent. So whatever hydrogen gas is released in the reaction, however it's released into your previous mechanisms like with HCl and H2SO4, these hydrogen gas is being oxidized into water molecule due to the strong oxidizing reagent HNO3. And hence, what happened? It will convert into water molecule. But then whenever you use, it's like whenever metal would be magnesium, exception case is there. That is also very important. You need to write. So exception case is what? Magnesium and manganese. Both are started with Mn. These metals both are started with M. Magnesium and manganese. These two metals, whenever react with very, very dilute HNO3, that time it can release hydrogen gas instead of water molecule. This is what? Exception. Please note down, which is really very important. Clear? Understood? Now,
Yeah.
why only in case of magnesium and manganese, it can release the hydrogen gas whenever your HNO3 is very, very dilute? Because your magnesium and manganese are good reducing agent. That is also you should be aware. Understand? So though your HNO3 would convert H2 into H2O, it will be reduced back into H2 by the magnesium or manganese. Clear? Yes? Anyone
Yes,
have
ma'am.
any query, anything which you have not understand, please let me know. See, once again, what we have learned basically, whenever metal react with any of the acid, it releases the hydrogen gas, right? It will form a salt with respective that particular, what we can say, anion. If there would be chloride, it will form metal chloride. If there would be sulfate, it form metal sulfate. If there would be nitrate, it will be form metal nitrate. Okay. But then in case of nitric acid, instead of hydrogen, water molecule would release. Why water molecule would release? Because HNO3 is a strong oxidizing agent. Here I have written strong oxidizing agent, right? It will be oxidized, release H2 into H2O. Okay. But then whenever we use magnesium and manganese, due to strong reducing character of magnesium and manganese, it releases the H2 gas whenever your dilute HNO3 is used with it. Clear? Yes?
Yes. Yes, ma'am.
I hope
Yes,
all of you
ma'am.
have noted down. Yeah?
Yes, ma'am.
Yes,
Fine. Just give me a while. I'll show you this. Now check whatever I have taught, the same it is or something different. Only this thing. If you want, you can note down. See this with metals. After this only you're supposed to be. Okay. Nitric acid react with the metal and forms the corresponding metal, but it forms water instead of releasing hydrogen gas. It is due to the fact that nitric acid is very good oxidizing agent. Magnesium and manganese can form the hydrogen with nitric acid. Why? Because magnesium and manganese are reducing agent or strong reducing metals. Okay. That I have explained in detail. That all details are not given in this. So I just explain in thorough manner. Okay. Are you writing? You need some time to write, or shall I start with the next point?
No, ma'am.
Minutes only remain. No need to write now. Now we are going to see the reaction of acids with carbonates and bicarbonates. Correct? Yes. Shall I erase it?
Yes, ma'am.
Yes, ma'am.
Metal carbonate and metal bicarbonate. Next point, reaction of acid with metal carbonate and metal bicarbonate. Fine. Now metal carbonates examples are many. Na2CO3, then CaCO3, calcium carbonate, right? Many are there. So what happens generally when metal carbonate react with acid? Okay, that acid would be anything, HCl or H2SO4. Any anion would be there, chloride or sulfate or nitrate. So whenever it would be react with, you will get metal chloride. Obviously, this metal will go this with anion, you will get metal chloride. Right? This carbonate group has what? CO3, right? Among that, one oxygen would go with this hydrogen to form water molecule, H2O. And whatever two oxygens would remain with the carbon, it will form carbon dioxide. So generally in this reaction, carbon dioxide evolution is very, very important. And that can be recognized by seeing the effervescence of carbon dioxide. And if these effervescence or this gas will turn the lime water milky. Okay, we can like say that carbon dioxide is present or released in this equation or in this reaction. Sorry. Okay, so metal carbonate would be what? Na2CO3. If it would be reacted with HCl, you will get what? Metal chloride. Metal is sodium. Chlorine is here. Na+1, Cl -1. So formula would be NaCl, right? Another sub byproduct is H2O and the carbon dioxide. It is in gaseous state. So with upward arrow, we're supposed to show with the gaseous node below. Correct? Now see the balancing. See the balancing. How many hydrogens are here? 2. How many chlorines are here? 1. Okay. 2 hydrogen here, only 1 hydrogen. For balancing, I am going to multiply it by 2. Chlorine become how many? 1. So chlorine become 2. Here chlorine is only 1. So I'm supposed to multiply this also by 2. So here 2 sodium. This is 2 sodium. Everything get balanced. Clear?
Yes.
Yes, ma'am.
When metal carbonate react with acid, it will form a metal salt plus water plus carbon dioxide. Clear? Now what about metal bicarbonate? Means sodium bicarbonate, NaHCO3. This is sodium bicarbonate. Whenever it react with again HCl, what you will get? Same thing. NaCl, metal, chlorine. This hydrogen, it will form H2, and 1 oxygen would be taken from the CO3 and carbon dioxide will be released. Correct? In this case, I won't feel like we have to balance anything. Do we have to balance? Hello? No, because here one
No, ma'am.
hydrogen, here one hydrogen, here two hydrogen. One carbon, one carbon, three oxygen. Here we can see one oxygen, and here two oxygen, three oxygen. Sodium, how many? One sodium. Here also one sodium. Everything is balanced. So metal carbonate and metal bicarbonate, when react with acid, it will form metal salt, water, and carbon dioxide. Clear?
Yes, ma'am.
Any
Yes,
one
ma'am.
of you have any query, not understand anything, please let me know. Like this content, I will like ask you. I will force you to solve. Please remove some time. Okay, whatever your schedule would be, among that you have to means like work on this reactions, because this reactions practice regularly is very, very important. If practice won't be regular, things will not be proper. Understanding?
Yes, ma'am.
Shall
Yes,
I
ma'am.
end the class now? I think time is up.
Okay, ma'am. Thank you, ma'am.
Fine.
Okay, ma'am. Thank
No,
you.
ma'am. Thank you,
We
ma'am.
will meet again. I think when would be our class again? I guess on Monday. Fine.
Yeah.
I'll post some questions. You have to solve it. Fine.
Okay, ma'am.
Yeah.
Bye, ma'am.
Bye bye. Take care.